Hello everyone, and today we are going to be talking about the history of AI.
And the future of AI. We hope you enjoyed this video and let's begin.
In the first half of the 20th century, science fiction familiarized the world with the concept of artificially intelligent robots. It began with the heartless Tin Man of The Wizard of Oz, and continued with the humanoid robot that impersonated Maria in Metropolis. By the 1950s, we had a generation of scientists, mathematicians, and philosophers with the concept of artificial intelligence, or AI, culturally assimilated in their minds. One such person was Alan Turing, a young British mathematician who explored the mathematical possibility of AI. Turing suggested that humans use available information as well as reason in order to solve problems and make decisions, so why can't machines do the same thing? This was the logical framework of his 1950 paper, Computing Machinery and Intelligence, in which he discussed how to build intelligent machines and how to test their intelligence. However, talk is cheap. What stopped Turing from getting the work done right then and there? First, computers needed a fundamental change. Before 1949, computers lacked a key component for intelligence. They couldn't store commands, only execute them. In other words, computers could be told what to do, but couldn't remember what they did. Second, computing was extremely expensive. In the early 1950s, the cost of leasing a computer ran up to around $200,000 a month. Only prestigious universities and big technological companies can afford to dilly-dally in these uncharted waters. A proof of concept as well as support from high-profile people were needed to persuade funding sources that machine intelligence was worth pursuing. 5 years later, the proof of the concept was initialized through Alan Newell, Cliff Shaw, and Herbert Simon's Logic Theorist. The Logic Theorist was a program designed to mimic the problem-solving skills of a human and was funded by the Research and Development Corporation, or RAND. It's been considered by many to be the first artificial intelligence program and was presented at the Dartmouth Summer Research Project on Artificial Intelligence, or the DSRPAI, hosted by John McCarthy and Marvin Minsky in 1956. In this historic conference, McCarthy, imagining a great collaborative effort, brought together some top researchers from various scientific fields for an open-ended discussion on artificial intelligence, the term which he coined at the very event. Sadly, the conference fell short of McCarthy's expectations. People came and went as they pleased, and there was failure to agree on standard methods for the field. Despite this, everyone wholeheartedly aligned with the sentiment that AI was achievable. The significance of this event cannot be undermined, as it discovered the next 20 years of AI research. From 1957 to 1974, AI flourished. Computers could store more information and became faster, cheaper, and more accessible. Machine learning algorithms also improved, and people got better at knowing which algorithm to apply their problem to. Early demonstrations such as Newell and Simon's General Problem Solver, the Foundations for GPS, and Joseph Weizenbaum's ELIZA showed promise towards the goals of problem solving and interpretation of spoken language respectively. In an episode of the TV show Young Sheldon, there is an episode where Sheldon uses ELIZA, showing how popular it was in the 1970s. These successes, as well as the advocacy of leading researchers, or the attendees of the DRSPAI, convinced government agencies such as the Defense Advanced Research Projects Agency, or the DARPA, to fund AI research at several institutions. The government was particularly interested in a machine that could transcribe and translate spoken language. Optimism was high, and expectations were even higher. In 1970, Marvin Minsky told Life magazine, "From 3 to 8 years, we will have a machine with the general intelligence of an average human being." However, while the basic proof of principle was there was still a long way to go before the end goals of natural language processing, abstract thinking, and self-recognition could be achieved. We haven't gotten any smarter about how we're coding artificial intelligence, so what's changed? Turns out the fundamental limit of computer storage that was holding us back 30 years ago was no longer a problem. Moore's law, which estimates the memory and speed of computers doubles every year, had finally caught up and in many cases surpassed our needs. It offers a bit of explanation to the roller coaster of AI research. We saturate the capabilities of AI to our level, of our current computational power, which is the computer storage and the processing speed, and then we wait for Moore's law to catch up again. So in essence, time heals all wounds. Nowadays, we live in the age of big data, an age which we all have the capacity to collect huge sums of information too cumbersome for a person to process. The application of artificial intelligence in this regard has already been quite fruitful in several industries, such as technology, banking, marketing, and entertainment. We've seen that even if algorithms don't improve much, big data and massive computing simply allow artificial intelligence to learn. There may be evidence that Moore's law is slowing down a tad, but the increase in data certainly hasn't lost any momentum. Breakdowns in computer science, mathematics, and neuroscience serve as potential exits to the ceiling of Moore's law.
So what is in store for the future? In the immediate future, AI language is looking like the next big thing. In fact, it's already underway. I can't remember the last time I called a company and directly spoke with the human. These days, machines are even calling me. One could imagine interacting with the expert system in a fluid conversation, or having conversation in two different languages, being translated in real time. We can also expect to see driverless cars on the road in the next 20 years, and that is conservative. In the long term, the goal is in general intelligence. That is a machine that surpasses human cognitive abilities in all tasks. This is along the lines of the sentient robots we are used to seeing in movies.
Thank you for watching the video.
I really hope that you sincerely enjoyed this video